In this video, we're going to talk about interpreting or compiling source code. So we write programs in these high-level languages that are very English-like. Okay, and the code we write in those, we refer to that as our source program or our source code. A computer can't understand that code. It's human readable, but it's not good for computers. They don't get it. Computers want ones and zeros. So we have to convert our source code into machine language in some manner. And there are two ways to do that. We can do it by using an interpreter, or we can do it using a compiler. So an interpreter reads a statement from our source code, translates it to machine code or virtual machine code, and executes it immediately. So it's shown here. We take a high-level source file, run it through the interpreter, and we get some output. That works just fine. However, every time we run the program, we have to start with that high-level source file, run it through the interpreter to get our program to work and get some output. Compiling works differently in that we start with a high-level source file, we run it through the compiler, and that converts it to machine code. Once it's in machine code, we can run our program to get some output. The difference between compiling and interpreting, the big difference is our high-level source file has to be interpreted every time we run it. Okay. In compiling, we compile it once, and once we have that machine code file, we can execute it over and over and over again without having to compile it each time. So that saves time and saves resources. So the conventional thinking is that compiling a language that's compiled will ultimately run faster than a language that's interpreted, and that's generally true. However, in the case of Python, Python's getting faster and faster and faster every day. And it kind of rivals a lot of compiled languages. So while it's generally true, compiling runs faster. It's not universally true. There are exceptions. Some other software we need to talk about is our operating system. So our operating system is a program that manages and controls the computer activities. So we have a user who's using an application. The user could interact with that operating system, but so it is the interface for the user to interact with the computer, but it's also the operating system is the layer of software that stands between our applications and the hardware. Because we have an operating system, we can write our application to work with the operating system, and the operating system interacts with the hardware on our behalf. That prevents us, when we write an application, from having to write all the code that directly goes to the hardware. So it is also software. Operating systems are software. It's software that sit between our applications and the hardware that we're running the applications on. Now let's talk about Java, because we talked about compiling and interpreting, and I kind of made it like a language is compiled or it's interpreted. But Java's a little bit different in that respect. So Java, we can take something like, here's some source code that prints out welcome to Java, and we'll look more detail on how that works later, but that's pretty human readable. Java takes that source code and it does compile it, but it doesn't compile it to machine language. Java compiles to something called bytecode, and it kind of looks something like this. This would be the bytecode for the program up at the top here. Okay, now that bytecode will run on the Java virtual machine. So what's the Java virtual machine? Well, that's the Java interpreter, basically. So we compile the bytecode, and then the bytecode runs on the Java virtual machine. The thing to remember is a Java virtual machine exists for every type of computer out there. For Windows computers, for Linux computers, for Macs, or any other type of computer you can think of, there's a Java virtual machine. What that means is, in a traditional compiled language, if I write a program, I can compile it to run on Windows. But I also, if I want it to run on Linux, I would have to go back and change a few things, compile it again to run on Linux on a different piece of hardware. Same thing if I want to run it on a Mac, I might have to go back and recompile it again for the Mac. So I end up rewriting and compiling the same software 3 times. That's not true of Java. Java, I can take the source code, I compile it to bytecode, and that bytecode can run via the Java virtual machine on any piece of hardware that has the Java virtual machine installed, and it's available for all types of machines. So we can write our Java program one time and it can run on just about any machine in the world. And that is one of the strengths of Java. So Java is compiled, but using the Java virtual machine, it's also interpreted. So you can see here, they kind of show you this. We take our Java, we compile it, and we get the bytecode. The bytecode is actually executed by this Java virtual machine that can run on any computer. So since this Java virtual machine sits between the bytecode and the actual computer itself, it could be interpreted and ran on any computer in the world.